Hello and welcome back to another episode of the Test Driven Development series. In this episode, I want to cover interaction testing, very sort of focused way, not a big giant kata, just something real simple that you can get your teeth into and understand basically how interaction tests kind of work and all that sort of gubbins. There is two main types of testable that we're going to cover in this, which is the stub and the mock. I think they're the most used out of all of them. And with that said, we're going to do this in the kata of Ninja Wars. I came up with this really quickly, so do excuse the sort of any chopping and changing that might go on in this video. So it's just a little sort of turn-based game. We're just going to focus on doing the back end for it. And we're going to have a interface of a ninja who's going to protect itself and deal some damage. And then a battle service, which is going to use the ninja's interactions of as a collaborator, which is the protecting itself and dealing some damage, right? So Ninja 1's going to attack Ninja 2, Ninja 2's going to defend themselves, Ninja 2's going to then attack Ninja 1, and Ninja 1's going to defend itself. We're going to have an interface for the battle service. It's going to look something like this, which is this void turn with the two ninjas on it who will basically attack one another. So, yeah, with that, let's get started. Okay, so first things first, I've done a little bit of blue petering. We have the eye ninja with protecting itself and dealing some damage. Let me just change that to be more funny. And then we've got the eye battle service, which is going to take the two ninjas. Let me just change that to Ninja 1 and Ninja 2 so that it matches our README. I'm also just going to plop this README here so that we can keep an eye on our requirements, each little section that we do. Of course, you know, if you have two monitors, you can stick your real work requirements on that second monitor or whichever, if you were doing something more realistic. But this is obviously an exercise. Okay, so with that being said, let's close all that up. And let's start by creating our first test. It's always a good place to start. Define what we want the battle service to do with this should. It's implying what should it do? Well, I think it should have a turn, right? And the turn is going to follow this interface that we've created down here. So I might as well just grab that and define it. Define the class down here, right? So we can see how this is all going to kind of come together. And we can extend and then hit page down. What's up with that? Public. And you can see that I've defined the turn down here. And so up here, we can define our unit, which is going to be the battle service. And there we go. Now, this is a simple example. Battle service isn't going to take any constructor arguments. It's just going to have one method with two arguments, which are base abstractions that we'll throw our concretes into. And in having the method based on that abstraction of the interface, we can override it with our mock and or testables rather, and we can verify all these various calls were made. So let's start where I like to start, which is the when step, and we can do battle service dot turn, not to string turn. And then it's confronting us with what we need. So we can define that as well. Now, the temptation might be to create that one ninja and have them do all the verifying and all of that stuff, and you could check, oh, did this run twice, did that run twice? I would recommend you create Ninja 1 and Ninja 2 and check that they run as you expect, right? So Ninja 1 would run its attack and its protect, and Ninja 2 would run its attack and its protect. So you wouldn't have one instance of a ninja in this case. You would have two instances of a ninja, and so we should define it as such. Obviously, we can now put in the object or the unwrap the ninja mock effectively, or the ninja testable if you prefer, into the turn here, and then of course we can verify all the calls and verify no other calls were made. Now, of course, we need to do a new throw new not implemented exception. Right. And we can then define Ninja 2. I don't know why I keep hitting escape out of habit. I guess it's this little pop-up that comes up. But then, because I'm on a different keyboard, I'm hitting the till key like this, like a noob. So, yeah, that is something of a test, but we need these ninjas to do something ideally, so let's get them doing stuff. Setting up our ninja. First off, we can do our ninja dealing some damage, which I called attack, and returns damage. Now, I can put a number in here, but ideally, let's define damage up here, because we're going to expect it somewhere else, because this value being returned is going to be passed into Ninja 2 at some point. And I can even prove that to you if you'd like. So that's damage 2. No, sorry, that's damage 1. And damage 2 we could have as 15, for example. And we can check protect is called. And what does protect take? Protect takes an argument of an int. So let's add that in with damage 2 here. And let's leave ourselves a little bit of space, and we can define. Oh, okay, we need to define these above, so we'll just leave them up there. But you can see how this is kind of coming together as a plan of what we're expecting. And remember that adding a little bit of space between steps, it can clear things up sometimes. You don't have to have it all in one giant list of stuff. That is dogmatic. So in this case, we're going to receive damage 1 and deal damage 2. So that's the test. So what I'm saying is Ninja 1, let's call Ninja 1 Bob. Bob is going to attack, and he's going to deal Bob's damage. Bob is going to get attacked by, let's call the other ninja Harry, and he's going to deal Harry's damage. Harry, meanwhile, is going to output Harry's damage, but he's going to receive Bob's damage. That's basically what we're saying in here. The turn is basically going to check these were ran. And don't forget, folks, this is your stub and this is your mock. So the stub returns a basically like a replacement value and an overridden replacement value, and the mock just checks something's ran, and a spy would be more specific as to how many times and so on and so forth. So if we run this test, right now we will find it failing. Let me just clear this display to make it more clear. And let's run this test, and it should fail in the way we expect, which is the not implemented exception, which is what we get. So we can commit, we can commit at this step, and we can go down here and we can implement the various bits to make all this work. So Ninja 1 is going to attack and deal some damage. Well, he's going to return some damage rather. Ninja 2 is going to protect with that damage being dealt. And we'll call that damage 1. And the same again. Let me just show you what that looks like, actually. If you were to run the test at this point, you would get like, this setup wasn't matched. I expect Protect with 15 in it to be called, and it wasn't. There's also something around attack. If you read hard enough in here, it'll probably be somewhere. But yeah, that's generally that. So there you go. So let's get damage 2 from Ninja 2 is now attacking Ninja 1. If we run this test now, basically everything passed. So that's good. So let's commit this. And then let's refactor. What can we refactor? Well, we could do this. We could do this. Nice and simple. Ninja 2 is going to protect itself from being attacked by Ninja 1. Ninja 1 is going to protect itself from being attacked by Ninja 2. Right? All reads basically the same. And if you do test, it should all still pass, which is great. Is there anything else? Yes, private read only. That's a tidy up. Otherwise, truthfully, I'm happy. I would say that is fine. And the only other thing to do, of course, is to move this out into its own thing. So I'm just going to do that too. So the battle service will have a new file of the battle service CS, and bingo. Just check everything runs, always prudent. And now we can commit this too. Okay, with that, we've defined the outside. If we ran this program right now, everything would fall apart and fail. So, because nothing is defined beyond that point. So let's do a new test, call it Ninja should. Because Ninja has behaviors in this case, because it's a model, and of course, if it was a really, really big model with lots and lots of behaviors, you would split out the behavior off into its own controller, and then you wouldn't really need any tests for Ninja anymore. If it has no behaviors on it, you don't need tests. If it has behaviors on it, you need tests. Basically, that's the general rule of thumb. In this case, from our requirements, we can see that Ninja is going to do the protect and attack. So we're going to define all of how that's going to look on the inside, and I think we'll just roll with a simple fact just for sheer speed, basically. Because we're not going to do anything too crazy when it comes to how this is going to look. The Protect might need a bit more to it, just to check the bounds and stuff. So we'll have a little experiment with that, and we'll work out what we're going to need beyond this point. So I think we might find that we're going to need a health at some point, which I didn't define, but that I was leaving for you to work out. So let's just quickly define our ninja out here. And let's create that class and extend our iNinja and implement the interface. And let's pop this on one side and pop this on the other side, and we'll just flick between what we need like this. Seem reasonable enough? I think so. I think that's quite efficient. Remember, we want to go one test at a time, and for that reason, we will comment Protect out, because I don't know what I need. Also, makes sense to put our ninja at the top, because we know we're going to need lots of them along the way. So let's define our ninja like this. And remember, there's nothing too crazy going on with constructor arguments in this. I want to keep the example nice and simple so you can keep focused on what we're wanting. Ninja attack, right? That's what we want to define in here. What do we want to assert? Probably a constant, truthfully. There's no need for us to do anything too crazy here. So let's go with that, right? That damage, our expected damage is going to be basically compared to actual damage. It's like describing my life. Expected damage to actual damage. And if we run the test, of course, we are going to get a not implemented exception. So let's clear this up so we can keep nice and focused on what we're looking at here. So not implemented. So we need to implement it. So let's do that. What's the simplest thing we could do to implement it? Of course, we can commit this point to, because if we've got a test failing in a way we expect, well, probably honestly that is the simplest way we could make this test pass. And I'm perfectly happy with that as an implementation, because we're really just focusing on interaction tests. So that brings us to the other part, which is the Protect. Now, Protect is going to need to determine a few other things, because, of course, you know, we need to, at some point, determine did the ninja die and all this sort of other stuff. But we haven't sort of defined all of that. But you could, if you wanted to, you could extend the exercise. But I think what we should do for Protect is take some damage from the health, right? Like we'll have a health system, and we'll remove some health from the ninja. So I think what we should do first is define. Let's define a unit of health. That would make sense as a getter. As a getter, as a property, because some point, if you wanted to use this in the application, you would expose the health. It's not, we're not exposing health for the tests, but we're exposing health for some sort of front end, but only the getting part, not the setting part. So as long as we are manipulating the state of health from within the bounds of Ninja, we are encapsulated that information, and therefore we're writing code that conforms to the solid principles. So let's roll with that. So we are going to protect from some amount of damage. And for now, I'm just going to define that damage in here. And then we're going to assert some sort of expected health to some sort of health value on the ninja. So in this case, our expected health is going to be 95, assuming we're going to define it as 100 initially. Or we could start there for that matter. 0, 100. I think that's a reasonable test, and we can see where this is going to go very quickly. So let's run the test. So of course we get the not implemented error as we expect. So from here we can just clear things up, and I did a commit there just in case you didn't catch that bit. And health equals 100, I guess, at the moment, would actually pass that test. I know it's not what you might have expected. In fact, something like that might be the honest way where we don't need to do any refactoring later for that one. Yeah, okay, so we'll commit that. And then the next part, of course, I think is to go with a theory. So let's do a theory. And let's do inline data. And we'll do 0, 100, int damage, uint expected health. Get rid of this given step. Start adding values to this. This next simplest is 1 with 99. The next is to do some random values. So this is a bound check. These are 3 normal tests. 95, well, 100 minus 15, come on, you can do it. 85 minus 10 would be 90, so we can do something like that. Then, of course, we're going to want 99, which is another bound test. And then 100, which is another bound test. And then 101, which is a different type of test completely. So if we comment this line out here, this effectively, these tests triangulate one main next test. So we can kind of shortcut a little bit with our approach, with the test-driven approach we're taking here. So if we do .NET test, we will have 6 failing tests, but we can deal with 6 failing tests in one. Maybe I should shove that uint everywhere. Why would we have anything that isn't uint? Makes sense to me. Otherwise, you could end up with minus damage that heals somebody unexpectedly. The advantage of var, hey. So there you go. So we can see here we've implemented the test, and when we run it, there is a problem with the battle service should. Just let me fix that up. Let's just all of this, which shouldn't take me too long because there's not too many tests. There we go. Right. Let me just remove this so we can make everything nice and clear. So yes, so health minus damage. This is our default case. This is basically all the ways that someone could damage the opponent that are valid, and this last one is invalid. So we will commit this as a passing test, and the reason is because of course, like as I said, these are 6 of the same test, and it will triangulate that result for us. So the last one will challenge. The last one will challenge the result, and of course we should probably put a few more in, like 105 and 110. And of course we're going to get an overflow. Basically, it's going to loop all the way back round to the start, and that's why we get this big, silly, ridiculous number. And it didn't catch the actual exception it ought to throw, but it doesn't, because it's C#. So with that, let's add a catch for that. So if damage is greater than health, then we're just going to set health to 0 and return. This is what you call fail fast. So this is an exception case. So what we want to do in an exception case, do this, and then there's nothing further to add here. So let's get out of here, right? Before we do any more damage to the code base, or do any more damage to the code flow, let's say. Again, 3 of the same vibe when it comes to the tests. Let's just run the test and see what we get this time. And sure as we pass all of those tests that we wanted, and now of course you can see if we go to our requirements, we wanted a ninja who could protect itself and deal some damage, and have a little mini fight where Ninja 1 attacks Ninja 2, and Ninja 2 defends himself, Ninja 2 attacks Ninja 1, and Ninja 1 defends himself as our requirement. Let's see if we delivered on that. Well, if we look in the battle service, you can see Ninja 1 protects itself from Ninja 2 even, protects itself from Ninja 1's attack, and Ninja 1 protects itself from Ninja 2's attack. Ninja does an attack which returns a constant of 5. A ninja has 100 hit points of health, and when it's protecting itself, if the damage is basically a critical hit, it will set the health to 0 and then get out of there. Otherwise, in normal circumstances, the health will just take some sort of damage delivered by the attack. So we have met the requirement, and that is everything you need to know really when it comes to interaction testing. We've started with the outside and we moved on into the inside. So the outside is this part here, and you can see we have our damages, and you can also see that 15 is not what we returned for realsies over here, right? We returned 5. In this one, we're actually just replacing that 5 with 15, and that is what a stub can do. You can just replace it with any value you want just to see what happens. So Ninja 1 here, he does some damage, he takes some damage. Ninja 2 here, he does some damage, he takes some damage. The taking the damage is a mock, the dealing some damage is a stub. The battle service does its turn. We've already went through this, but of course you can see that all those methods are called as we would expect. And we check that all those methods are called as we expect, and nothing else is called on both Ninja 1 and Ninja 2. So that concludes interaction testing in a sort of more short form way. Hopefully you were able to get your understanding from that. And you can follow along, of course, and let me know any feedback that you have of where I can improve these demonstrations and stuff. I am on a new setup. We are at 1080p, so that's a good thing. And yeah, with that, thank you very much for watching, and yeah, all the best. Goodbye.